Hi, what are you doing? I assume doing is what you had in mind. What you just did is the driving engine behind today's large language model's daily routine. These models have grown large enough to absorb most general knowledge, but the way they think is still very much like a baby. They have to explicitly say out loud each step of the reasoning process to proceed to the next. This is called chain of thought. If they keep everything in their head, they get stuck. Take a classic question that confuses so many transformer models. Which one's bigger, 9.9 or 9.11? The model might know the rules for comparing decimals, but to solve the problem, it has to reason through a massive probability space. Imagine this to be parachuting from a plane into a mine to look for gold. But you get no hints other than a small metal detector, so basically where you land is where you start digging. If this transformer only has 20 layers, it can dig 20 times at once. Then it must output intermediate findings before proceeding. And if any steps goes wrong, the entire process can derail. This approach demands massive training data. And as the tasks get harder, more intermediate tokens will be used. The reasoning process becomes slower and more expensive. This is basically how chain of thought works. Dig 20 times, output the intermediate context, dig another 20 times with a new context, and repeat until the problem is solved. So you will need more GPUs, more power, and a lot more money. At some point, even the people building these AI started asking, is there a better way? Luckily for us, we can take inspiration from our own brains. When we think, our brains don't just process language first. Thoughts often starts as an abstract idea or sudden insight, a continuous, high-dimensional stream that let us explore complex concepts quickly. Only afterward do we translate these rich, extensive thoughts into lower dimensional languages. This is what fuels our deepest thinking and sparks creativity. Consider aphasia patients. The language capabilities are impaired, yet it does not affect their ability to perform advanced abstract reasoning. This indicates that for us humans, language is just a tool for communication, not a container for thought. Meet HRM-Text, a brain-inspired hierarchical reasoning language model by Sapient Intelligence. When it starts thinking, it does not rush to jump down from the plane. Instead, HRM-Text will place the problem inside an internal latent space mind map, where words are converted into high-dimensional vectors, like a clearly labeled treasure map. Through natural language, we can only hint at gold's location to ambiguous expressions like near the valley or halfway up the mountain. But in latent space, HRM sees an exact map with accurate coordinates, distances, relationships, information that are usually inexpressible through words. This enables deep, efficient reasoning beyond language. HRM also appoints two systems, H the high level and L the low level, to constantly update this map. H is the high-level commander, the gold finder. It oversees the entire mine and plots the overall mining course. It is a slower cycle but sees the big picture. L is the low-level executor, the gold miner. It explores specific locations and reports the findings. It is a faster cycle that handles detailed computations. H and L form a hierarchical teamwork. H guides, L executes. If L finds only gravel, H adjusts the plan accordingly. And if L finds sign of gold vein, H directs deeper exploration. This cycle repeats, refining the map and clarifying the solution. Of course, there wouldn't be planes and miners in the actual model. In reality, the map would just be a few sets of vectors that keep track of HRM's thought process. L updates the local findings, while H updates the global directions. With all of these taking place internally, HRM-Text processes deep, efficient thinking without the need of intermediate tokens. Therefore, HRM does not think through speaking like chain of thought, and it runs thorough thinking inside its mind before speaking, just like us. That's a fascinating idea, but how efficient can HRM-Text learn? The blue square right here represents the amount of tokens used to train the 1B HRM-Text, and this is roughly how many tokens Llama 3.2 3B used, and this is how many Qwen 3.5 2B used. In other words, HRM-Text uses only 1/900th of the tokens used by Qwen 3.5 2B, and only about 1/600th of its training flop. Just a tiny fraction. So how does it perform? Let's see this models on a training tokens versus benchmark score chart on Math, Drop, Arc Challenge, and MMLU. The closer a model is to the upper left, the less training data and better performance it has. Where is HRM-Text? Right here. And if we switch to a flops chart, it will be right here. HRM-Text is leading a new paradigm shift. that starting from now, you can train a model from scratch with only around $1,000 within 1 day, and with performance on par with in-class SOTA models that cost thousandfold. With a lower cost, better performance, and faster iterations, Sapient Intelligence is establishing new possibilities to AGI. Concepts that were once too expensive are back in the game. And this vision, as we believe, will lead to a more efficient, powerful, and ultimately the lean general intelligence.